Thank you for sitting with me, Sam. I really appreciate your time. Maybe we could talk about what onsemi is showing here at PCIM. What's the news?
Yeah, I mean, PCIM is, first and foremost, thank you for the time as well, and pleasure meeting you. So PCIM is basically centered around power.
Yeah.
It is the biggest power show here in Europe, and we are demonstrating our power solutions, the portfolio from, say, MOSFET, IGBTs, silicon carbide, GaN, vertical GaN, and all the power applications. So, yeah.
And there's onsemi's getting more GaN news over time. I saw there was quite a bit there, the GaNEXUS.
It is. I mean, it's a portfolio expansion, right?
Yeah.
So we have traditionally been a power company.
Yeah.
Starting off, from 2015 to 2016 from IGBT and MOSFET, and eventually branching into SiC discrete and SiC power. Basically fueling the EV adoption in the world from 2021, 22, and 23.
Yeah.
And obviously, for a high power application, GaN is a must, so we are now, partnering for both vertical GaN and for lateral GaN. Yeah.
Thank you. Maybe we could move on to, the silicon carbide market. I know that it's still dealing with the EV adoption slowdown, and onsemi's recent silicon carbide wins are NIO and Geely. And those are both Chinese OEMs.
Yeah.
Are European automotive OEMs moving at a similar pace, or what are you seeing?
Oh, they're, pace? No. Yeah, right. Innovation, yes.
Okay.
So now I can talk about, being in Europe, what I can talk about is the European OEMs, the Volkswagens, the Mercedes, and the BMWs. Yes, they are moving in the direction of using silicon carbide for their, EV platforms.
Yeah.
The key thing is they're just not moving in the pace of the Chinese OEMs. What does it mean? It means they have a longer design cycle. For a European OEM, the design cycle is from 24 to 36 months.
Yeah.
Whereas for China, OEMs, the design cycle for a car from concept to production is 12 to 18 months. So that's where the pace comes from. It's pretty clear the innovation is driven from China.
Yeah.
So, if you look at what onsemi has done, partnership with Geely, partnership with NIO and all the other OEMs.
Yeah.
Now we have launched China for China strategy, a couple of months back by our CEO Hassan, basically, increasing our, presence in China, right? And that's going to be the key focus. Now, from your question about silicon carbide, you talk about, and I can talk about publicly or available, talk about Volkswagen.
Yeah.
They are moving to the direction of being 100% vertically integrated, from a power standpoint. So yes, they will be using silicon carbide, unlike every OEMs, but the adoption is, smaller or lower.
Yeah.
Because if you see there's been a paradigm shift about the EV adoption. The volumes are not scaling as anticipated. From back in, I think you remember back in 2022, most of the European OEMs came up with a net 2030 strategy.
Yeah.
They wanted to change the complete portfolio from ICE into EV. Obviously, that's changed to 2035 or even push further. So that gives a lot of opportunity for a plug-in hybrid EV car, or a range extended EV car, or maybe a full EV. So that's an opportunity for us to take the portfolio that we have and expand into this different models and different applications.
Where does onsemi see the first high volume application win for vertical GaN? Is it data center, DC to DC, EV onboard charging, or somewhere else?
I think combination of everything. One of the things, and this better than most of us, is there's been a lot of pull for power for data center applications. I think strategically most of the companies, semiconductor companies, are doing a pivot, towards data center applications. So I think that's the focus. The adoption of GaN for automotive, purely from a volume standpoint, is lower, but the adoption will happen. So I think from a corporation standpoint, we are going to focus on all these applications that you mentioned just now.
Perfect. So thank you so much for your time. Any last comments? Anything I might have missed? Anything that you wanted to add?
No, I just want people to buy more power semiconductors, and I'm making this as an opportunity in PCIM to connect with a lot of customers. But I think it's exciting. The future is exciting as a semiconductor company, just because the portfolio expansion of power can go into various applications from automotive, data center, low power to high power, and that's very exciting for our corporation.
Thank you for meeting with me, Sam. And I know I've got a couple more questions to ask.
Likewise, thank you as well. Yeah.
Thank you. So maybe we could talk about the if onsemi sees its investment in GaN competing with this established silicon carbide portfolio.
I think it's a complementary portfolio, silicon carbide and both lateral and vertical GaN.
Yeah.
We see a lot of applications in silicon carbide on automotive, industrial, data centers, and AI.
Yeah.
That's what is propelling the demand right now.
Yeah.
And purely in terms of GaN, we see a lot of applications for lateral GaN right from 40 volts to 1,200 volts.
Yeah.
So the breadth of applications of GaN, helps us to sustain what is required in the market in terms of a power portfolio. So it's complementary from that aspect.
Okay. And I wanted to talk a little bit more about the partnership with InnoScience. What spurred this, and how will onsemi bring its packaging expertise to InnoScience's low voltage GaN?
I mean, no, I can talk about what the partnership is all about. InnoScience is a foundry partner for us. Mm-hmm. So if you look at where we are vertically integrated from all the product portfolios for power,
yeah.
where InnoScience comes into play along with global foundries. Mm-hmm. We are using their expertise as a manufacturing partner, as a foundry partner, to take the products from a packaging standpoint and introduce the products in the market. So and that is probably at even a global level. Mm-hmm. So it's another element to our manufacturing strategy to provide supply chain resiliency to our customers.
Okay, well, thank you so much. I appreciate answering that question, your time.
Yeah, thank you very much.
Thank you.
Thank you, Aalyia.